Okay, so let's continue with our predicting reaction section. So for part B, it tells us that solid strontium hydroxide is added to a solution of nitric acid. And so hopefully the type of reaction we have here should be, evident pretty quick. So strontium hydroxide, so again we have OH minus, and we're adding it to nitric acid. So nitric acid, again, is a strong acid, so all we're going to care about with that is going to be the proton, because it's going to be completely dissociated, and the rest of the anion is not going to be a part of it, so it's just going to be a spectator ion. Normally, strontium hydroxide is a strong base, so meaning it would completely dissociate, and so if we're adding this in aqueous form, we'd only include the OH minus, but since we're adding it as a solid, we have to include the strontium with it as well. So strontium carries a charge of 2+, so it's going to be SrOH2. And then other than that, it's just going to be your basic acid-base neutralization reaction. H+, OH- gives us H2O, so we're going to form water, and we're going to have some strontium 2+ left over. And then so we got to make sure we balance it. So we get 2 protons to go with the 2 hydroxides here, and we end up with 2 waters each time. Okay, and so that gives us with the balance, and it says how many moles of strontium hydroxide react completely with 500 milliliters of 0.4 molar nitric acid. So we have half a liter of 0.4 molar. So if we know volume times molarity gives us moles of nitric acid, so we're going to end up with 0.2 moles of nitric, HNO3, and we're going to see that strontium hydroxide, there's a ratio of 2 moles of nitric acid for every 1 mole of strontium hydroxide. So 0.2 divided by 2, we can get 0.1 moles of our strontium hydroxide to react completely with that amount. Okay. And the last one here, part C, it tells us that we have barium chloride adding to sodium carbonate, causing a precipitate to form. So in this, and a lot of times they won't even tell you precipitate, but this time they say you form a precipitate, so it automatically tells you what type of reaction you have. And so here's going to come into some solubility rules for a little bit. But like I said, a lot of times they kind of give it away. So if you know the basic ones, sodium is always soluble. And chloride is soluble a lot, so it can't be sodium, which means it can't be sodium with chloride. So it's going to have to be the barium and the carbonate combining to give us a precipitate. Okay, and so it's going to be the barium, which again has a charge of 2+, and the carbonate, CO3 2-, that's going to react and form this solid barium carbonate. Okay, so knowing the solubility rules helps, but really if you just keep an eye out for the sodiums, the nitrates, and the ions that are always soluble, you'll usually be able to figure out what combination it has to be. And then so the last part of this one is it asks us what happens to the pH of the carbonate solution, sodium carbonate solution, as the barium chloride is added to it. And we can think of it as this. So carbonate is reacting with water to give us some bicarbonate and hydroxide. So if we remove carbonate, which is essentially what we're doing with precipitate, so if we remove this, it's going to shift the equilibrium in this direction to compensate, and so you have fewer hydroxide, you have less hydroxide, it's less basic, meaning the pH decreases.